Right, a few people found this question tricky because of not really knowing how to turn structural formulae into displayed formulae. So what you've got here in this question is 4 different structural formulae, and what they do is they tell you what is attached to each of the carbons along a chain. Okay, and then because the question says which ones contain hydrogen bonding, there was maybe a bit of a misunderstanding about what it means to have, or what it means to have hydrogen bonding. Hydrogen bonding only takes place when you've got an OH bond, an NH bond, or an FH bond. So it's not that it contains O and H, N and H, or F and H. There has to specifically be an OH bond, an NH bond, or an FH bond present. Okay, and that might already be ringing a little bell in your head going, oh, right, that's why the answer is this rather than that. Okay, so if I draw each one as a displayed formula, then we'll be able to work out what the answer is. Okay, so in the first example, CH3, and then in brackets you've got 4 CH2s and a CH3. So that is telling you that there are 6 carbons along the backbone. Okay, so 6, you would be thinking hex. Okay, so all of those are going to have 4 bonds. So we've got our CH3 on the end just here, and then it says CH2 in brackets 4, so there must be 4 CH2s. So there's one. Here's another one. Oh, I wish there was a way to draw H's really quickly in life. Never mind. CH2. Here's our 4th CH2 in a row, and then a CH3 on the end. So that does not contain an OH, NH, or an FH, so it cannot be A. Okay, let us get rid of all of that. Whee. Oh, that's quite fun. Right, next one. B. So with B, again, we've got 1 carbon there. We've got 3 carbons mentioned there, 4 and 5. Okay, so we've got 1, 2, 3, 4, 5. So the first thing says CH3. So I've got CH3 on the end. Fine. Then I've got 3 CH2s, or I've counted incorrectly. Never mind, we'll get over that. So we've got 3 CH2s. So there's one, there's another, and there's another. So I've got CH2, 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 and that's what they put in brackets. Now I've got a CHF. So that's a carbon attached to a H and also attached to an F. Okay, and then on the end I've got CH3. So this is where there might have been some confusion, because you're thinking, oh, hang on a minute, I've got FH. You haven't. You've got a carbon bonded to a H and a carbon bonded to an F. So you've got CHF, and then you've got CH3. Okay, if there was an FH bond in there, it would be in brackets within the formula, but it's not, so it's not included. Okay, so it cannot be B. Get to use my rubber again. This is exciting. Whee. So the next one, whilst I'm rubbing this out, this is fun. The next one has something in it that we may not recognise potentially, and that's fine. We can talk about it. So I've got 1 carbon, 3 carbons. So that's 1 and 3 makes 4, 5, 6. That's where my confusion was last time. 3, 4, 5, 6. Right, I've got CH3 on the end. My structural formula is telling me I've got CH3, so I need to draw it in my displayed formula. I've then got 3 CH2s. Oh, yeah, there we go. Whizzing along now, crumbs. CH2, 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 taking care of those. And then I've got CO. Ooh, so that is C and O. Well, now that thing's not got the 4 bonds that I would expect. And also we would think, well, hang on a minute, oxygen would want to bond with 2 things because it needs 2 more electrons to fill its outer shell. So that is a CO double bond. That's called a ketone. Okay, what we've got here is hexane 2-one. It's got a ketone, a carbonyl group. We call it a ketone here because it's on one of the middle carbons, and it's on the second carbon in. And then, so that's our CO, and then on the end we've got a CH3. So again, this is why some people were confused, because they thought it meant there was OH present, because there's O's and H's in the formula, but there's not an OH present. There's that group, and that ain't an OH group. Okay, that's not the hydroxy or the alcohol group that we need in order for it to be hydrogen bonding. Okay, so it can't be C just there. We'll get to do my rubbing out again. This is exciting. I rub out all that and stuff as well because we don't need it. Okay, so the last one, then we've got a whole load of brackets. Okay, so we've got our brackets for the that's quite satisfying. We've got our brackets for the alkyl, so the CH2s. So we've got 1, 2, 3, 4, 5, 6 carbons again. Oh, that makes sense. They're all 6 in the question. Okay, so we've got all of those. So I've got my CH3 because it tells me in my structural formula. Then I've got 3 CH2s. There's 1, there's 2, there's 3. I'll bung all the H's on because otherwise it's sloppy if I don't. Oh man, I had this teacher at school called Dr. Smith, and could he draw H's? Could he ever? Crumbs. Right, now the next one. CH OH, so CH, and then my OH is in brackets, so that tells you that the stuff in brackets is bonded to itself. So OH means there's an O and a H. Oh, that's encroached upon down here. So this is my CHOH down there, okay? And then I've got my CH3 on the end. Okay, so that's now CH3. So there is now an OH group, that group just there, and that is why that one, ding, is the right answer, because it has an OH group that does hydrogen bonding. And even though C has an oxygen in it and B has a fluorine in it, they are not FH bonds in B, and they are not OH bonds in C, but there is an OH bond in D, and that's why it's the right answer. Nailed it.